So absolute value, we're going to basically split up into two cases. As I break this up, I essentially take the original problem, rewrite it as is without the absolute value. So 2/3 a minus 3 less than 1. And then for the other side of this, I take the expression that's inside the absolute value, the 2/3 a minus 3. I flip my symbol here, so I take less than, turn it into greater than, and I change the sign on what we're comparing the inequality to. So change the sign on that one. This is a less than statement to start. So less than is what I'm thinking. Throw a little and statement in between because an intersection should be formed here with my answers. So you got two separate inequalities. We solve each of them separately. Graph results on the same number line to get a feel for what the actual solution set is. Over here, I'm going to be adding 3 over. So I've got 2/3 a less than 4. I can clear this 3 out by multiplying both sides by 3. 2a would be less than 12. Divide by 2, and a is less than 6. In the meantime, this other inequality, same kind of operations, add 3 over, got 2/3 a, greater than 2, multiply by 3 to clear the 3, got 2a greater than 6, divide by 2a is greater than 3. So we'll watch the solution set unfold here on the number line as we consider the graphs for both of these inequalities. Throw 0 on here for perspective's sake. Throw 3 on here because I know that's something I got to revolve my solution set around. I'll throw 6 on here because I know that's something I have to revolve my solution set around. If a is going to be less than 6, we're not going to include 6. We're going to shade, though, everything to the left. And if a is going to be greater than 3, we're going to keep 3 open here. We're going to shade everything to the right. This is where the importance of understanding this is an and statement comes in handy, because we are taking the overlap between those two regions. We are taking that intersection that's supposed to be created. So the solution, as it looks on the graph, 3 and 6 not included, everything in between is. Interval notation, just to rehearse that a little bit more, it's from 3 to 6, parentheses around the 3 and the 6 because they're not included. You isolate the absolute value, divide by -2. That does have an impact on this symbol here because you're dividing by that negative. You will have to turn that around. So we've got the absolute value of 3x plus 1/2. It's now greater than or equal to, it'd be 6 over here, right? -12 divided by -2. We do like we did in the last one, kind of branch off in the two cases here. We drop our absolute value. For this first inequality, that leaves us with 3x plus 1/2, greater than or equal to 6. For the second inequality we have to set up and solve, drop the absolute value, take the expression inside of 3x plus 1/2, flip your symbol, change your sign. So positive 6 becomes -6. Okay, since it's greater than, this is an or statement. So we should see a union forming as we arrive at our answer. Okay, if I solve over here, there's a few ways we could do this. You know, if you don't like the fraction, you could multiply through by 2. You can clear that out. You want to do that? Doesn't really matter to me. Want to multiply by 2? All right, we'll multiply by 2. Multiply the whole thing by 2. So 2 times 3x, we got 6x. 2 times the 1/2 plus 1. greater than or equal to 2 times 6, get 12. All right, so subtract 1 over, get 6x greater than or equal to 11. Divide by 6, x greater than or equal to 11/6. Still end up with a fraction, but so what? All right, we like clearing the fraction out. We'll do the same thing over here as we solve this inequality. We're going to multiply everything by 2, so it's 6x plus 1 less than or equal to -12. Solving here, subtract 1 over. Got 6x less than or equal to -13. Divide by 6x less than or equal to -13/6. So we have this answer or this answer here. We graph that out. Put 0 on here for perspective's sake. All right, 11/6. Positive. Here's 11/6 over here. Greater than or equal to 11/6. Well, we know 11/6 is included. Greater than or equal to, we go to the right. -13/6. Here's -13/6. Somewhere on the negative side. Less than or equal to, include the -13/6, shade to the left. So you can see how we've got one set going one way, one set going another way on the number line. That's the union idea that's being formed. If I put down the interval notation for this, you've actually got two intervals you're describing. Right? You've got this one over here where you're starting at -infinity. That's what's furthest to the left. And you're traveling up to -13/6. That -13/6 is included, so I throw the bracket on here. And since we're adding on another interval here and we're forming a union, I throw a little u in there to combine on this other interval, where apparently I'm starting at 11/6, and then I'm ranging up to infinity. So 11/6, that's included. Infinity, not so much. There's a little recap of the interval notation as it relates to that number line and the solutions for this inequality.